Oh, hey there guys, it's me, Mrs. Mongelli. So, for the algae farm, for the very first part, you're gonna have to design a carbon dioxide capturing system using tubing, a candle, a funnel, and other lab materials. So how are you gonna test to make sure that you're actually capturing carbon dioxide? I think I know the answer. It's bromothymol blue. So let's go to the lab and test out how it's able to see if there's carbon dioxide. And I'm about to show you a really cool lab demonstration. So as part of the algae farm project, the first part of the project, you need to build a device that's going to capture carbon dioxide and bring it over to the algae farm. So how are we going to test for that? Excellent question. Like, how do you know for sure that carbon dioxide is actually moving somewhere or it's actually there? Well, we can use a chemical indicator called BTB or bromothymol blue. So you can see that right here. It's a blue color, and it can actually change to greenish or yellowish in color. So when there's not a lot of carbon dioxide mixing in with the BTB will look blue. As more carbon dioxide gets dissolved in it, it turns more and more green and then more and more yellow. So basically a negative result if we were testing something with BTB to look for carbon dioxide presence. If there's not a lot of carbon dioxide, the color of the liquid will remain blue. And if there is a lot of carbon dioxide, it will be green or especially yellow. And so we're going to test three things today, and we're going to test for the presence of carbon dioxide. So you can see on your handout, there's a chart, and you're going to fill that in. So we're going to test bromothymol blue on this first test tube here of BTB. We're going to test it just in the normal air. And we care about that because there is carbon dioxide in the air, but there's a lot of other stuff in the air that we breathe too, like nitrogen, oxygen, etc. We're then going to test BTB that is in exhaled air. So I'm going to actually exhale into the test tube, and that's going to represent respiration. So you can predict how you think that's going to go. And finally, we are going to test BTB and the presence of a flame. So that represents a combustion reaction. Cool. So let's get started. So first I'm going to need my lab swag, obviously. So I've got my gloves and then my goggles. And so for our first test, it doesn't involve that much. We're literally just going to observe this plain old test tube that has BTB in it. So you're going to observe that, and it appears blue. So there's really nothing. If I want, I can invert the tube, which means turn it. See how I've got my thumb on the top of the tube? I'm just going to invert it like that, and it's still blue. So basically we have a negative result. So there's not a whole lot of CO2. There's a little bit, but not enough to really make the BTB change color. Okay. So now we're going to do our second test, which is, no, not that. It's the straw. Perfect. Okay, so I'm going to exhale into this tube of BTB. So if you want to observe, this is what it looks like before. So it's blue. And then let's see the result after. All right, so that is pretty much yellow, wouldn't you agree? It's a little greenish yellow, but if I kept exhaling, I think it would definitely become bright yellow. So basically, what does this test mean? It means that I'm clearly exhaling carbon dioxide into this tube. Also, did you notice when I was exhaling into this tube, the straw was submerged into the liquid, so the air was getting down into the liquid and bubbling up. So you're going to want to keep that in mind when you transfer your carbon dioxide over to your algae. If you just leave the tube with the carbon dioxide above the surface of the liquid, it might not make it into the liquid as much as you would want. So this is a nice technique that you need to keep in mind when you design your farm, but that's going to be the next step. Okay, and finally, we're going to do the flame test. So we're going to see if carbon dioxide is a result of a combustion reaction. So let's get started. Okay, so I'm going to take a wooden splint. I'm going to move anything flammable. Okay, and I'm going to take my lighter here, flamethrower. Oop. Awesome. Okay, and now I'm gonna trap some of the gas that's being released from this flame in the tube by putting my finger on top of it. Also, this lab surface is fireproof, so that's why I can leave the splint there. Okay, so see, I've caught all of this gas that's been released from the flame. Notice how it's not mixing yet with the BTB, really. It's a little bit. So now I'm gonna invert the tube. Aha, look at that. All right, so what happened? Turned bright yellow, even more yellow than when I exhaled into the tube. So as you can tell, combustion is a reaction where carbon dioxide is released. It's where a hydrocarbon is burned. So in this case, it's wood. Other ones can be coal, other types of fossil fuels, and also the candle that you're using to represent the burning of fossil fuels is a wax, and that can also be burned. And in the reaction, it's going to release carbon dioxide. So in a combustion reaction, you can see I drew a flame on the board that's burning wood. So oxygen is going into the reaction. The hydrocarbon, which in this case is the wood, is what's being converted into carbon dioxide, water, and energy in the form of heat. Wow, that was pretty awesome, huh? So now that we know how to test for carbon dioxide, our next step as a class is to determine the optimum height of the funnel over the candle in order to allow the candle to stay lit and in order to collect the most carbon dioxide possible. So let's go to the lab and find out. See you later.